we are discussing non-Pareto based approaches to solve multi-objective optimization problem. In the last few lectures, we have discussed two approaches. These are non-Pareto based approaches, namely lexicographic ordering and simple weighted approach. Shortly, it is termed as SOEA. Another approach in this line is called vector evaluated genetic algorithm, short term is called VEGA. This approach is totally different than the previous two approaches. So, this approach is basically called based on criterion selection. So, that is why it is a criterion selection based approach. So, in this lecture we will learn about the VEGA approach to solve multi-objective optimization problem. Now, this approach first time proposed by David Schoffer in 1985. He reported the approach. The title of his approach is called multi-objective optimization with vector evaluated genetic algorithm and their application. It is published in the proceedings of the first International Conference on Genetic Algorithm in 1985. It is in the same proceedings where the first approach on the lexicographic ordering was also proposed. Now, so this approach, this VEGA approach is called the first of its kind, or it is a first implementation of the MOEA approach. This approach in fact, unlike the previous two approaches, it is a posteriori technique. That means, for this approach we do not require any prior knowledge. So, this is the one difference among the three approaches which are based on non-Pareto based approaches, and another characteristics of this approach is that it is the criterion selection based approach. That means, here selection is different than the selection technique that is follows in a simple genetic algorithm. More interestingly, this approach, the VEGA approach, in fact is an extension of simple genetic algorithm. It is an extension because it considers a different selection strategy than the selection strategy that is there in simple genetic algorithm. Now, we will discuss exactly what is the selection strategy that it follows in this approach. Now, here basic idea about is that, as we know, in case of multi objective optimization problem, there are multiple objectives. So, VEGA considers one objective at a time out of the several objectives in succession. That means, it will consider one objective, then next objective and so on, and then it is the selection of a particular solution is based on the performance of the objectives as a whole. That is the different here with respect to the simple genetic algorithm. So, here basically a particular objective out of the several objectives are randomly selected while we generate the population. Anyway, let us proceed to learn about VEGA, and then we will be able to understand how the selection strategy is different in this year. Now, we can start with let us consider there is a multi objective optimization problem with k objective function. So, k objective functions we denote them as f1, f2 dot fk. Okay. So, these are the objective function that we will consider here, k number of objectives are there. Now, the next step is that we have to select a number of sub population, and the sub population means subset of the populations, and this subset of population is selected according to each objective function in succession. Therefore, if there are k objective functions are there, so we have to select k subpopulations. Now, size of each population is m by k, where m denotes the size of the mating pool, and usually m is less than n, where n is the size of the population. So, here basically the idea is that out of n solutions in the population, current population, we have to select m solutions for the mating pool, and from the mating pool we generate the mating pair and therefore reproduction. Now, so the second step, as I told you, we have to select k number of subpopulations, each of size m by k. Once a subpopulations are selected, then we have to follow one shuffling technique. So, here basically shuffling means we have to shuffle from ith subpopulation to jth subpopulation, so that some mixing is possible. Once this is done, this a mating pool is ready, and then we use this mating pool to produce the next generation. So, this is the idea about it, and then we will continue the same procedure until we reach the termination condition. So, these are the simple steps that is there in the VEGA approach. Now, let us explain the VEGA approach, how it works. Now, this figure will help us to explain the concept that just now I have mentioned here. So, the idea it is like this. So, suppose this is the current population at any time of the generation iteration. So, let us suppose the ith iteration is going on. So, in the ith iteration, the current population, this is the current population, and then size of the current population is n. And as I told you, this is a multi-objective optimization problem with k number of objective vectors. So, this is the k number of objectives are there. Now, so given this is the population at any instant, our next task is to create subpopulation. So, create subpopulation like this. So, here basically if this is the entire population, then we have to select a block of size m by k. So, there are this way k number of blocks are there. So, each blocks are there. So, k number of blocks are there. Now, in each block we have to select the solution which has the highest values with respect to a particular objective function. For example, in block 1, from this solution we select all the solutions which has the highest value of objective vector f1. So, it is basically f1, and then this is fj and this is fk. This means that in each block all the solutions are having excellent with respect to one objective vector only. So, all the solutions here are very good with respect to objective function f1. In the jth block all solutions are excellent with respect to the objective vector fj, and in this kth block all solutions are very good with respect to the objective function fk. So, this is the idea here. So, here m by k number of solutions, here m by k number of solutions, m by k number of solutions. So, this way we have to create k number of subpopulations. Once the subpopulations are created, then we have to shuffle. Shuffle means one solution from here will be shuffled with one solution in the population block j, or one solution from here to this one, or any other solution from here to here. So, from any ith block to any jth block some shuffling was carried out. So, this is the shuffling. After shuffling it will give a mating pool. So, this is the mating pool where few are very good with respect to objective function in particular region, and then other will be inferior. So, it is the idea about it, and then once this mating pool is created, we follow the same technique of the reproduction that is there in case of genetic algorithm, and from this mating pool we will be able to create the next generation population for the next generation, the I plus 1th generation. So, this is the idea about the VEGA, and we can understand that VEGA has the different approach so far that this technique selection is considered. Now, we will discuss about how the subpopulation is created, and then how shuffling occurs, and then how the VEGA can complete a cycle and all these things. So, here VEGA consists of 3 major steps as we have learned. So, first step is basically creating k number of subpopulation each of size m by k. The second step that shuffling the subpopulation, and then finally the third step is the reproduction to produce offspring in the next generation. And as we have discussed about that, this is the first step is different, second step is different, and then this third step is the same as the simple genetic algorithm that we have learned. So, this is the idea about it. Now, let us see how the different things or shuffling or subpopulation can be created, and then what is the procedure is there. Anyway, so once the mating pool of size m is created, we have to follow the proportional selection strategy. So this is basically the idea about how to create the subpopulation. So, to create the ith population of size m by k from the entire population, right, where I is basically 1 to k or any one numbers. Here, to select the subpopulation for the ith block, right, we follow any selection strategy. For example, any proportional based selection strategy such as Rowlett wheel or rank based selection can be followed. So, here whenever we follow this Rowlett based selection strategy like this one, basically we will consider only one objective factor, one objective function. That means, so ith objective function should be considered in order to select the proportional selection strategy to fill the ith block or ith subpopulation. So, this is the idea about how to create the subpopulation, any one population like this one. So, this is the pictorial description of the same thing. Here this is the entire population of size n. Then our objective is to create the mating pool of size m. So, what we should do is that for this population, when we have to fill it up, we will follow any proportional based selection strategy to select m by k number of solutions from here to obtain the subpopulation 1. Now, here and then whenever we apply this selection, that means to select all the solutions for this block, then we can follow any proportional based selection, and then with respect to objective function say f1. So, here with respect to objective function f1 we apply any proportional based selection, and then subpopulation will be created. So, this will be continue with respect to f2 for the subpopulation 2, similarly with respect to fk for the subpopulation k. So, this way we will be able to create the subpopulation of size m, where the number of solutions belongs to a particular block, has the excellent what is called the with respect to one particular objective function f1 and so on. So, this is the main task. major one task that is there in VEGA, and once this subpopulation is created, then our next task is to shuffle the subpopulation. So, the shuffling that can be we can like shuffling means is shuffling the solution from one block between any two block. Now, this shuffling can be done in many ways. I have mentioned one simple approaches here. For example, we first generate any two random numbers, say I and j, between 1 and m. Then swap I, that means the solution I and then solution ij, which are there in ith and jth subpopulation namely. So, we have to select any two solutions at random which are belongs to any two subpopulation and then shuffle them, and this shuffling can be repeated maybe some p times, where p is decided by the programmer. P may be 10, p may be 5, that means how much mixing of the solutions you want to have. So, this is the idea about shuffling. Once the shuffling is done, then our mating pool is created. So, here basically the illustration of the shuffling procedure. This is the one solution in any ith block, this is another solution in jth block, basically shuffling. That means I1 will go to the jth population and ij will go to the ith population. So, after shuffling, this is the mating pool is there. Now, once this mating pool is known to us, we will be able to go for reproduction. Reproduction strategy is same as the reproduction strategy that is there in case of simple genetic algorithm. Here this is the mating pool, and from this mating pool we have to create next generation populations for the next generation. Size will be same, that is the n if is the size of the population. So, here we can do again any two solutions at random. So, this one and this one, any two solutions at random as a mating pair, and from this mating pair we will be able to generate offspring depending on the crossover operation, mutation operation that we have already learned for the simple genetic algorithm. So, this way from the mating pool of size m we will be able to create the population of size n, and so this is the idea about reproduction that is there in case of vector evaluated genetic algorithm. And then let us see how the vector evaluated algorithm works for that. We understand that VEGA can be implemented in the same framework as SGA. That means, it is basically an SGA, but only the thing is that the selection strategy that is there we have to little bit modify. So, it is basically modified version or extended version of simple genetic algorithm. Now, VEGA can be viewed as optimizing all the objective function in succession, and that is why we can write that it basically optimizing a function x which is in the vector form of all the objective functions like f1x, f2x, this one. So, this is why this method is called the vector objective. So, it is basically we have to find fx such that fx has one component f1x, another component f2x, and then k component fxx. So, we have to find fx so that fnx is good, f2x is good, and then fkx is good, all objective functions are good, but we consider all objective function whether good, then it is not at the same line, rather in a succession line. So, first we say that whether it is good with f1x or it is good with f2x or it is good with fkx, then we can say that fx is good with respect to k objective functions like this one. So, this is the concept that is there, and that is why it is the vector evaluated, it is called the vector evaluated genetic algorithm. It is in fact a generalization from the scalar genetic algorithm. Scalar means if we multiplied this f1 by w1, this by w2, this by wk, and if we consider W1 equals to W2 equals to Wk, then it is basically a scalar generation, but it is not scalar generation, it is basically vector generation, and then the each component of the vector is basically excellent with respect to that component only. And a thorough research and experiment with different case studies, it is observed that this VEGA approach is comparable to the previous two approach, namely lexicographic ordering and then SOA approach. However, and then SOA approach, it is better compared to the previous two approaches, and it also leads to a solution very close to optimum, local optimum with regard to each individual objective vectors are there. So, this approach can be considered as a better approach so far the approaches that we have learned, and so this is the advantage that the simple genetic algorithm framework can be easily adapted to implement the VEGA approach, and it gives better result compared to the previous two approaches. However, it has certain serious limitations, and thus okay fine, like the previous two approaches which are belongs to non-Pareto based approaches, this approaches also gives only one solution, that is why it is called a non-Pareto based approach. Now, the solutions generated by VEGA are locally non-dominated, but not necessarily globally dominated. That means, all solutions are close to the local solution, but not necessarily close to the global solution. So, it cannot return the global solution in fact. Another two problems with this approach, the problem is called the speciation problem and middling problem. So, this is the two drawbacks in this VEGA approach. Now, we say that it suffers from the speciation problem if it basically considers or it basically do very good result in terms of a particular objective vectors, but not all objective vectors. This is why, and now in case of VEGA approach, we see that whenever we select a solution for the next generation, we basically select with respect to a particular objective vector. Now, so that is why it suffers from the speciation problem. That means, whenever we select an object, we do not consider all objective function at a together, rather one objective function at a time. So, this VEGA approach suffers from this speciation problem. Now, another problem that the VEGA approach suffers is called the middling performance. Middling performance means the results that it returns neither very bad or very good. It is a middle performance. That is the things is there. So, if we are interested with not so accurate result, so far the objective function optimization is concerned, we can use VEGA approach. In fact, VEGA approach is very fast compared to any other multi objective optimization solving approach. So, this is the pros and cons of the VEGA approach that we have learned. So, we have learned different techniques to solve multi objective optimization problem. We term all the approaches as the MOEA algorithms or MOEA strategies, and so far the MOEA strategies are there. We consider all non-Pareto based approach. So, all these solutions are non-Pareto based approach, and out of these non-Pareto based approach solution, the solution that we have discussed as a priori approach. So, we have these are the a priori based approach, and so and then in this course we have learned about two a priori based approach, namely SOA and the lexicographic ordering. They are non-Pareto and a priori approach. Another non-Pareto approach, non-Pareto based approach that we have just now learned it, the VEGA approach. VEGA approach in fact is a posteriori approach. So there are different variations. So for the non-Pareto based approach are concerned, we have learned it, and then we are going to learn about the Pareto based approach. There are many good techniques or good approaches belongs to this group, Pareto based selection. So we will discuss about one approach. So we will discuss about 4 approaches in this course: ranking, and then niching, and then demis, and then elitis. So those things will be discussed in the next slides, next class. Thank you.